Assalamu alaikum. Today we are going to present a presentation of our course name Introduction to Engineering Studies on the topic of complex engineering solution. Our section is I. Our group name is Silicon, Department Tripoli, project title Sustainable Engineering Approaches for Load Shedding Reduction in Bangladesh. This presentation is presented to our honorable course teacher Dr. Chaudhry Akram Hossain, and our group members are myself Arman Azam, Arup Kumar Singh, Imtiaz Ahmed Mahdi, Azimuddin Mia. The title is Sustainable Engineering Approaches for Load Shedding Reduction in Bangladesh. Here we can see table of contents. Point number 1, Introduction. Point 2, Understanding the problem. Point 3, Problem definition and conflicting requirements. Point 4, Sustainable engineering solutions. Point 5, Analysis and selection of integrated solutions. Point 6, Implementation and testing. Point 7, Conclusion. Introduction. What is load shedding? Load shedding is the intentional temporary cutting off of electricity supply to certain areas when the demand for power becomes greater than the available supply. Load shedding is a major problem in Bangladesh. It causes economic loss and daily life disruption. The consequences are severe: significant economic loss and widespread disruption to homes, businesses, and essential services. Sustainable engineering can provide long-term solutions. This approach offers the long-term, resilient solutions we urgently needed. Engineering innovation is essential for reliable power. It is through engineering innovation that we can build a future with a reliable, stable, and uninterrupted power supply for Bangladesh.
Assalamu alaikum, myself Imtiaz Ahmed Mahdi. Now I will describe the rest of parts. Now my part is understanding the problem. To address load shedding, we first have to look at the root of the problem. In Bangladesh, we are not just dealing with occasional power cuts, we are facing a chronic gap between our electricity generation and the actual demand of the population. This gap is driven by a few key factors: our heavy reliance on imported fossil fuels like natural gas and coal, our aging grid infrastructure, and the rapidly rising demand from both homes and industries. Because we depend on imported fossil fuels, our security is consistently at risk due to international price fluctuations. This is not just a technical glitch, it's a massive disruption to the daily life and the economic growth. That's why we define this as a complex engineering problem. It involves deep uncertainties and requires us to look beyond standard formulas to find a sustainable way forward. Now our next slide is about problem definition and conflicting requirements. As engineers, solving this problem means balancing several requirements that often conflict with one another. Reliability versus scalability. We need a system that provides scalable, uninterrupted power today, but it also has to be scalable to handle future urbanization and industrial growth. Economic viability. We are looking for a sustainable solution that are cost effective over their entire life cycle. Even if sustainable tech has a high upfront cost, the long-term operational cost must remain affordable for the government and the public. Environmental sustainability. We must align with climate commitments by reducing carbon emissions and overall dependency on fossil fuels. Societal equity. Reliability should not be a luxury. Our solution must ensure that electricity access is equitable across both urban and rural populations. Technical feasibility and grid sustainability. Finally, we have to use technologies that are realistic for Bangladesh climate and infrastructure. Most importantly, adding renewable energy should not cause voltage instability or any other dangerous things that can harm people and our climate and also the environment.
Myself, Azimuddin Mia. Now I am going to talk about sustainable engineering solution. In this slide, we present sustainable engineering solution to reduce load shedding in Bangladesh. First, decentralized renewable energy such as rooftop solar PV and solar mini grids can reduce pressure on the national grid, especially in remote and residential areas. Second, grid modernization using smart grids allow real-time monitoring, faster fault detection, and better power management. Third, energy storage system like battery storage help store excess solar energy and supply power during peak demand or outage. Finally, energy efficiency measures such as efficient motors and LED lighting reduce overall electricity consumption. Together, these solutions improve reliability, sustainability, and long-term energy security. Now I am going to talk about analysis and selection of integrated solution. In this slide, we analyze and select the best solution. We consider functionality cost, environmental impact, and social acceptance. The analysis shows that a single solution is not enough. The analysis shows that an integrated or hybrid solution is the most effective to reduce load shedding. Therefore, integrated sustainable solutions are the most effective way to reduce load shedding in Bangladesh. This figure shows a hybrid power system using solar and wind energy. Solar panels generate electricity during the day and wind turbines support power generation. Excess energy is stored in battery storage system. This setup provides clean, reliable and continuous electricity and reduce depends on conventional energy source. This figure presents the conceptual framework of an integrated sustainable power system for Bangladesh. On the left side, power is generated from renewable sources such as rooftop solar and large-scale solar and wind farms. Energy efficiency measures help reduce overall demand. In the middle, a smart grid and battery energy storage system manage power flow using real-time monitoring and advanced meter. On the right side, electricity is supplied to industrial, residential users and remote areas through mini grids. This system improves energy reliability, efficiency, and social equity.
Namaskar, myself Orpana Singh. Now I will talk about implementation and testing. Firstly, we suggest a phased approach. We start with pilot project, where new technology is tested in smart grid areas and mini grids. Next, stakeholder engagement is very important. Government, industry, and the public must work together. Proper documentation and communication are also needed. This includes engineering plans, policy documents, and public awareness. Now I'm talking about the conclusion part. Load shedding is a complex engineering problem involving many stakeholders. It can be solved by a single solution. It needs sustainable and integrated engineering approaches. Success depends on balancing economic, environmental, and social needs. Finally, a hybrid renewable energy system supported by smart grids and energy storage is the most practical and effective solution for Bangladesh. That's all about our presentation. Thank you.